Okay, here we are on page 2 of the continuous random variables addendum. Number 5, the PDF for the random variable y is this linear function here with limits between 0 and k. Under what conditions can y be a continuous random variable? So there's two things. One is that the area under the curve, or in this case the straight line, when you add it up from 0 to k, it should total up to exactly 1 because the probability of anything happening is 1. The other thing is that every single value between 0 and k should be a positive number because the probability of getting any number between 0 and k should always be between 0 and 1, including 0 and 1. Okay, so that's A. And B, without using calculus, find k. Okay, so if we're not going to use an integral to find k, we could just draw a picture, right? Because if we drew a picture of 5 minus 12y, we're just going to have basically a line, and we could figure out the area under the line just using, methods we used to use before we knew calculus, which is count squares, right? So the y-intercept is going to be 5. Okay, so 1, 2, 3, 4, 5. So here's the y-intercept. And then, and this is a little bit confusing because in this case, the x-intercept, the x-axis is the y-axis, and the y-axis is actually f of y. But anyway, the slope is negative 12y, so that means in the space of less than 1 unit, the thing has already dive bombed off the screen, right? And so if we want to figure out the area under this triangle, what we really need to do is we need to figure out the x-intercept. And once we do that, we could just figure out the area of a triangle, right? So what is the x-intercept of 5 minus 12y? So basically that would be when f of y equals 0. So we would say 0 equals 5 minus 12y. 12y equals 5. Y equals 5 twelfths, right? And so basically the x-intercept in this case, it's kind of confusing because the x-intercept is y equals 5 twelfths, right? Is one side of the triangle. So the width of this triangle is 5 twelfths. The height of the triangle is 5. So if I wanted to find the area, the orange area, it would be 5 times 5 twelfths times 1/2 because it's the area of a triangle. So that would be 1/2 times 25 divided by 12. So that would be 25 divided by 24. So the area of the triangle is 25 divided by 24. Okay. And then it says, without using calculus. Okay, so the area of the triangle is 25 24ths. It's slightly bigger than 1, right? So we cannot use the whole triangle. We need to cut the triangle off like right there, which would be the value for k. So we need to chop off 1/24, right? So with my new picture here, I basically have like a trapezoid, right? So now I have this little rectangle at the bottom, and I got the triangle on the top, and the little triangle I chopped off. Let's do this. Now we're going to have the area of the little triangle. The area of the little triangle is equal to k times the height of the little rectangle. I'm sorry, I said triangle, but it's rectangle. 5 minus 12y, which is, this y value would be k. Okay, so this is the area of the rectangle. And then the area of the triangle on top of it is going to be, also, it's going to be 1/2 times k times 5 minus 5 minus 12k. And this is going to be simplified to 1/2 k times 5 minus 5 is 0, minus 12 is 12k. So this is equal to 6k squared. And so the total area is going to be 5k minus 12k squared. So we're going to add the rectangular area and the triangular area together. It's going to be 6k squared minus 12k squared plus 5k. And we want that to equal 1. And then we're going to figure out what k is going to be, okay? So it'll be minus 6k squared plus 5k minus 1 equals 0. Let's use a calculator. So we go to apps, and we go to polysmlt, and we hit the key. And then we do polyroot finder, 2 roots. And for the first coefficient, we put -6. Second coefficient, we put +5. Last coefficient, we'll put -1. We solve, and we get 1/2 and 1/3. So there's 2 possibilities, 1/2 and 1/3. That's weird. Oh, but just one thing. Remember, this point here was 5/12, and k needs to be to the left of that. So it can't be 1/2. It has to be 1/3. Okay? Let's go on to C. Notice that this integral here equals 1. Explain why k is not equal to 1/2 despite this result. Okay, this is getting back to what we just talked about. So like k equals 1/2 would be this case here, where you would have a positive area here. And do you see how like k is 1/2 would be there, okay? And this intersection here would be 5/12, which is slightly less than 1/2, right? And then the negative part of the triangle here, do you see how when you like do the integration, the red part would cancel out some of the orange part, and then it would give you 1? But remember, you can't have any negative parts to the integration because a PDF always has to be positive. So that's why even though C looks like it could be a solution, it's not, okay? Because then part of the integral is going to be negative. Find the mean and median value of y. Okay, so if we're going to find the mean and median value of y, I think now they want us to use calculus. Okay, so now we're going to use an integral, and to find the mean, we're going to use 0 to 1/3, and we're going to put 5 minus 12y, and we're going to multiply it also times y because we're going to find the mean, and then we'll set that equal, or we're going to see what that is equal to. Okay, so it's going to be 5y minus 12y squared, and then we're going to take the integral from 0 to 1/3, so it's going to be 5y squared over 2 minus 12y cubed over 3. 12 divided by 3 is 4, so I'm just going to write 4 here instead. And then I'm going to integrate that from 0 to 1/3, and that's going to be 5 1/3 squared divided by 2 minus 4 1/3 cubed, and then we're going to subtract the 0 term, the substitute 0 in and subtract those, but it's just 0, so we don't have to do anything with that. And let's see, let's complete this. So we'll have 1/3 squared is going to be 1/9, so 5 over 18 minus 1/3 cubed is 1 over 27, so it's minus 4 over 27ths. And let's do that with the calculator. So we're going to do 5 divided by 18 minus 4 divided by 27. And I'm going to change that to a fraction. See if we can. Math, number, fraction, fraction. There it is. It's in the first screen. 7 over 54. Okay, so that is the average, or the mean. Now we're going to calculate the median. So the way you calculate the median is you do a integral with no y variable multiplied times the distribution, and we set it equal to a half. Okay, so I'm going to get this out of the way. Okay, and then I'm going to do the same integral, 5 minus 12y, except I'm not going to multiply times y, dy, and that's going to be equal to 0.5. I did one thing wrong. I'm not supposed to put 1/3 here because the value here, we don't know it yet. So I'm going to put m. Okay, so we're going to integrate from 0 to m, the function, and then we're going to see what value of m is going to yield 0.5. Okay, so that will be the first, it would be like the first half of the triangle. Okay, and half of the triangle would be marking where the median m is. Okay, so let's take the integral. So it'll be 5y minus 12y squared divided by 2. We're going to integrate from 0 to m. And so that would be 5m minus 6m squared. And then you don't need to put zeros in there because everything turns out to be 0, equals 0.5. Now we're going to have a quadratic. So minus 6m squared plus 5m minus 0.5 equals 0. Now we can figure out what m is by going to polyroot finder and next, and -6, 5, -0.5. And the two possibilities are 0.717 and 0.116. But remember, it can't be anything bigger than 5/12 because it's got to be in the orange triangle, not over here in the red one. So ignore the 0.717, which is too big. The answer is 0.116, right? So it's going to be the median is equal to 0.116. Okay, number 7, the continuous random variable x has a PDF as follows: 2e to the negative 2x. X is greater than or equal to 0. Calculate the median of x and calculate the mode of x. Okay. So first we're going to calculate the median. The way we do that is just what we did last problem. We take the integral of 2e to the negative 2x, which is the PDF, and we take the integral from 0 to m, which is the median, and we calculate when does that equal to 0.5, which is half the area under the curve. One thing that's different about this in the last problem is, do you notice that the domain of this problem doesn't have a maximum? So basically, if you take the integral of this function to infinity, apparently it equals 1. So that's really interesting, isn't it? That you can take the area under the exponential function to infinity, x equals infinity, x approaches infinity, and it adds up to a finite number. Kind of like the way when you add up all the numbers in a geometric sequence, as long as the sequence is decreasing, you get a finite number also. Remember that? So it's pretty much analogous. So let's solve this now. So we're going to take the derivative of this. It'll be e to the negative 2x. We're going to divide by -2, so we just end up with -1 as a coefficient, 0 to m here, and that's equal to 0.5. Let's substitute the m in, so we get -e to the negative 2m minus e to the 0. So basically that's equal to 1 minus e to the negative 2m equals 0.5, which is equal to 0.5 equals e to the negative 2m. So if we take the natural log of both sides, we'll find that negative 2m is equal to the natural log of 0.5. So natural log of 0.5 is negative 0.6939. Negative 0.693. Right? Okay, and so then we divide both sides by -2, so we get divided by -2, and that gives us 0.347. So m is equal to 0.347. Okay, so that's the answer to A. The answer to B, which is the mode of x, okay, so if you have the function which is 2e to the negative 2x and you graph it, you'll see this exponential function that looks like that. We know that the area we're interested in is x is greater than or equal to 0. The mode occurs here at the leftmost point, so the mode of x is equal to x equals 0. And that's it. That was an easy part B. Okay, last of all, the continuous random variable x has the PDF, f of x equals ax to the fourth. The interval is between 0 and k. Given that the probability of x is less than or equal to 2/3 is equal to 1 over 243, find a and k. Okay, so let's see. So we got this PDF, and we know that a certain probability is equal to that. So let's say, okay, the probability that x is less than 2/3 can be calculated by doing the integral between 0 and 2/3 of the PDF. And that we know is equal to 243. So let's solve for a and k. Okay, all right. So first we can solve for a just from looking at this, right? So let's take the derivative, or the integral. So it'd be x to the fifth divided by 5. We're going to integrate from 0 to 2/3. Then it's going to be a 2/3 to the fifth divided by 5 minus 0, and that's equal to 1 over 243. I think 3 to the fifth is going to be 243. What do you think? 3 to the fifth. 3 to the fifth. Yeah, it's 243. So actually, this is going to be equal to a over 5, 2 to the fifth, which is 32, 3 to the fifth, which is 243. It's equal to 1 over 243. And then, so that's equal to 32 fifths. A is equal to 1. So A is equal to 5 divided by 32. Let's do the last part. It says to find k, and k is the right part of the interval. What do we know about k? We know that if k is a certain number, so that when we take the integral from 0 to k of 532 x to the fourth, we should get 1 because it's a PDF, right? This is normally the first thing we do in a problem, but in this case, it's the last thing we do in a problem, okay? So we're going to take the integral of that, x to the fifth over 5, so it'll give us x to the fifth over 32. We're going to evaluate it from 0 to k, and that is equal to 1, so it's k to the fifth over 32 equals 1. K to the fifth equals 32. So k is equal to 2. And that's it.